start this. This question is again about benzene-related compounds. Cumin is a spice used to flavor food. Two compounds responsible for its flavor are cinnamaldehyde and cumenoyl alcohol. The structures are given. The only difference between cinnamaldehyde and cumenoyl alcohol are there is an aldehyde part over here. How do I know that there's an aldehyde part? You should know the structures of molecules. Here, there's a hydrogen atom. It's an aldehyde. Here, there is one hydrogen. There's another hydrogen over here. This is a primary alcohol. Aldehyde. Whenever you start a reaction, please try to analyze the structure and get some idea about the structure of the molecule to find out the functional groups available, because that helps you to find answers for questions easily. Okay, we are dealing with an aldehyde and an alcohol. Identify two bonds that are responsible for the difference in the infrared spectrum of cinnamaldehyde and cumenoyl alcohol and state their absorption ranges. Identify two bonds that are responsible for the differences in the infrared spectra. Okay, it means, analyze this. This whole lower part of this molecule, the two molecules, they are identical. So I'm not going to worry about the lower part of this molecule. I'll take only the part which is on top of both the structures. Here we have carbon, double bond, oxygen, and hydrogen is there. This is an aldehyde functional group. And over here, we have OH. Of course, it is attached to CH2 part. It is attached to benzene ring. So if you want to talk about a difference, we have to see what is the difference. Cinnamaldehyde has carbon, double bond oxygen. I think this is going to give you a value around 1700, maybe 1740, around 1700. I just remember that. And here we have an alcohol, and I think this OH functional group over here is going to give a P about 3200, probably 3200 to 3600. Now, when I wrote these values over here, I said that I think, and I was not very sure about it. Why is it? Because you are not supposed to remember this. You can get the data booklet. From the data booklet, we can find out values. That's pretty easy, but you should know how to search for it. Oh, so we have 1670 to 1740. Wonderful. It's around 1700. I guessed, but I get the correct value now. And 3200 to 3600, that is OH in alcohol value. The unit is cm to the power minus per centimeter. Okay. Bond responsible for the difference. First one is OH. In cinnamaldehyde, we don't have OH. So let me remove it. In cinnamaldehyde, we have carbon, double bond oxygen. I'll write like this. And the next one, COOH. Now we don't have COOH. We have an alcohol. So I write just OH group is enough. Bond responsible for the difference. OH. Value we can write over here, 3200 to 3600. per centimeter. And then here we have 1670 and 1740. That's simple. It's a very, very easy question. Next, we go to some reactions of benzene, where you can see various types of reactions happening on the benzene ring and outside the benzene ring, in the sense on the attached parts of the benzene ring. Go to step 1. As I said earlier, first you're trying to figure out what sort of a group has come into this. Let me draw the structure of the added alkyl group. CH3, CH3. This is CH. Okay, this whole part has been added to the benzene ring. Remember, I have told you that this reaction can happen through what? Can you remember? Friedel-Crafts alkylation. In order to add an alkyl group, we have to use a catalyst, which is AlCO3. Of course, heat is needed. And the group which is getting attached is CH3, CH3. Hydrogen should be here. There must be a chlorine atom also. Don't forget it. And second reaction is pretty much the same. This is similar to the step 1, but here CH3 carbon. Okay, the reagent which is reacting here is CO, CH3, chlorine. Here also we have AlCO3 and then heat. Now what is happening over here? This one is a little bit strange, right? See the lower part of this. It's the same. Only thing that has changed is the upper part of this molecule. There's one huge change that has happened during this reaction. What is that huge change? Here we have one carbon here, one carbon here. There are two carbon atoms in this part. But on the right-hand side, we have only one carbon. See the difference. Therefore, one thing you must remember. This 2 carbon has to go to 1 carbon part by breaking the CH3 part. If you analyze now, you must remember, okay, we are breaking CH3 part here. And this CH3 is attached to carbonide part. So what do you think is a reaction? Remember, either form test. Why? In either form test, this CH3 part goes out. I told you earlier. See? During either form test, one CHI3 part goes out, and the main compound in the reaction has 1 carbon atom less than the reactant in all these compounds. So with that knowledge in mind, again, we come to this. What has happened here? The student has heated this compound with iodine in sodium hydroxide medium. Iodine in sodium hydroxide medium. But you must have a question. In our previous discussion, we don't have carboxylic acid, but what are we having here? We have sodium salts. Why sodium salts are there? Because the medium contains sodium hydroxide. So if you want to remove this sodium and turn them to carboxylic acid functional groups, only one thing is there to do. First, you add iodine and sodium hydroxide and heat. And then afterwards, to change that sodium salt back to carboxylic acid, we add dilute acid. Then you can add something like dilute H2SO4. Dilute H2SO4. If it's confusing, I'll go back to this, where I will take only, no, I'll cover all the names. Right. See the first compound. In the first compound, we have a sodium salt because there is sodium hydroxide. If you add H2SO, let's say HCl, HCl is also okay. If you add HCl, then we get HCO. This O Na plus O minus Na plus goes to OH, and then sodium chloride is formed. Sodium chloride, because this sodium here goes with chlorine. So likewise, you just add sodium or HCl, you will get the hydrochloric acid. I'm sorry, carboxylic acid back. If you wonder, if you worry about these reagents and conditions over here, what is the name of this compound? This compound is 2-chloropropanol. 2-chloropropane. 2-chloropropane. And the temperature over here, when I say temperature, you might wonder what is temperature. It's actually temperature about 60 to 65 degrees Celsius. Very high temperature, 60 to 65 degrees Celsius. So step 1, reagents and conditions we have done. Okay. Step 2, all right. This is step 2. And step 3, of course, we have done step 3. Oh, now what is this? In step 4. In step 4, we have a carboxylic acid. Carboxylic acid function group. But what is there in the product of reaction 4? This has gone to CH2OH. Carboxylic acids go to alcohols, primary alcohols, when you're reduced. So we have to have lithium aluminium hydride reducing agent for this reaction. Lithium aluminium hydride for step 4. It is also done. Let's go to the last part of the question. Name the mechanism of step 2 and state the type of reaction in step 2. Mechanism of step 2. Step 2 is here. What's happening? In step 2, we have an acyl part getting into this. Acyl part getting attached to the system is called electrophilic substitution reaction. Electrophilic substitution reaction. And type of reaction in step 4. What is type of reaction in step 4? Yeah, we are not talking about a mechanism here. In step 4, because we are using lithium aluminium hydride, this is definitely a reduction. Reduction means oxygen going out and hydrogen coming in. So in the step 4, 2 oxygen change to 1 oxygen. And 2 hydrogen also come in addition. 2 hydrogen coming, 1 oxygen goes out. This is a reduction reaction. So type of reaction in step 4 is reduction. Okay, that is the end of this reaction. I hope you have understood the concept that I have tried to bring into you. It's a simple question. So we are done with this.